Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to continue off where I last left on my videos. So on my new calculus channel I was talking about parallelism and arithmetic without numbers. Now I'm going to show you now, using the same two ratios, how we can go through each of the operations: difference, sum, quotient, and product, in that exact order. And don't worry about stopping the video and copying this thing down, because I have a link to the free article, which you can get over here, okay? So now, let's just focus on learning these concepts. So if we go, the first thing we need to do is notice that we can make any two ratios have the same consequent, all right? So, and we do that by parallelism. So if we wanted this consequent here, we would take this guy, put it over here like that, and then this distance here would be the new antecedent. Why isn't it writing? This distance here would be the new antecedent, okay? With this blue consequent. So, and of course I demonstrate that to you by showing you how it works. If you take the triangle and you move it along, you can make it any consequent you like, all right? It doesn't really matter what consequent you make it. So let's leave it at that and start on the different examples. So these are the ratios I'm going to use. And let's just make sure that I have the ratios like that. I think this one here needs to be this ratio, like that. Now they're the same ratios, right? So first we'd have to convert these two ratios, yes, so they have the same consequent. And we can convert them to any consequent we like, but for the sake of simplicity, I'll just choose this consequent on the right. In other words, this one with the broken orange line. And so how will I do that? Well, I'll come back here and I'll take the line that's parallel to this guy, okay? And I can either do that or I can bring the line that's parallel to this guy over here like that, and then the new antecedent will be this line here, right? This line, okay? That will be the new antecedent. So I'm going to choose that method to get this antecedent here. So let me move that out of the way, like that, and I'm going to move this guy backward a bit, and I'm going to make that. So first of all, this was like that, right? So if I need a new antecedent, I'm going to have to increase that like that and like that, right? So now they have the same antecedent. And of course, I showed you how you can do that, right? You just take the line that's parallel to this one, bring it over here like that, and you know that that's where the new antecedent is going to be, where I'm pointing to now. All right, so now they have the same consequent, and the difference is very easy. It's just simply the difference in this red antecedent and the broken green antecedent, which, as we can see, is 1, right? So the ratio that is a difference in this case will simply be this, right? It'll be 1 to 6, okay? 6, right? So, and that's not hard to see because you have 1, 2, 3, 4, 5, 6, and the difference is 1, so it's 1, 6. So that's the difference. Now, if you have to take the sum, then you just concatenate the red line to the broken green line, and how much will you have if you do that? You'll have 5, won't you? Look there, pen. 5 blocks, right? So the sum will be 5 6s, right? And that's what you've done. What you'll see in the article. And now the quotient is a lot simpler than you think. All right. So now to do the quotient, it's even easier than the difference in sum, because all you do is take the take the ratio of this red line as antecedent to this broken green line as consequent. This means that what you'll have, the new ratio that you'll have, is 3 to what? 2? 3 to 2, right? 3 to 2. So, and 3 to 2 is the quotient. Okay? So basically what I'm saying here now is that half divided by a third is 3 to 2, or 3 halves, okay? Which is equal to 1.5. And that is the measure of this ratio, okay? Measure of this ratio is 3 over 2. That's what you do in algebra. In algebra, you count the number of equal parts. In geometry, you don't care about that. Okay, you've just got line segments in geometry. That's all you've got. So that's the quotient. Next, if you thought the product was hard, it's basically just a flipping around of the second ratios, antecedent and consequent, and then just doing a division again. See? So if we flip these around, okay, so in other words, we'll make this guy, let's get these out of the way. This guy, just use the second one and make it 6. So it's going to be 6 like that. And this, what was this? It was a third, so now it must be 3. So it must be like that, right? Okay, so if you do that, now you just take the make them the same ratio, like that, and then, well, actually, I've made a mistake there. Can you spot it? All right, so I had 6 like that. That is a half. So what if I did this and this, right? Now, we could just take this, the ratio of the red line to the broken green line, and that will be the product, right? Exactly the same thing as we would have done in division. And that turns out to be 1 over 6. And of course, that's correct, because if you look at the algebra and you say 1/2 times 1/3, that is 1/6, because it's the same as 1/2 divided by 3 over 1, isn't it? And in which case you would follow the same process as you did for division. And that's pretty much it. So if you're not already a subscriber, please become one. Click like on my video, follow me on YouTube and on Academia, which is this site here, and I'll place a link to this article here. Also, you can become a member of my members only channel by clicking on any of the videos like that, okay, and clicking on the join button, which is right over here. And for a mere $4.99 a month, you'll have access to a lot more information that I haven't shared with the public. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.